Milne Thompson method. This method tells how to find a function f of z if its real part is given or if its imaginary part is given. So let us discuss this method in two parts. First is if f of z is of the form, let f of z is equal to u plus iv. This function we have to find where we have given whose real part u is given. So with the help of this u we have to find the complete function f of z, and even we can find its conjugate v also, because as we know, if the function is analytic, then u and v are called harmonic functions and they are harmonic conjugates of each other. So here with the help of real part or imaginary part we are finding their harmonic conjugates, and ultimately we are finding the analytic function f of z. So here we have given real part u of the function f of z. So with the help of that, first we'll find f of z, and then with the help of that we can find its harmonic conjugate. So what all we are having only as a u, so with the help of that only we have to find f of z. So since we have u, let u of xy, because u is a function of x and y, then with the help of this u what will be having, we can find so step 1, we can say step 1 is let the given function u of xy. So with the help of that we can find partial derivative of u with respect to x and partial derivative of u with respect to y. These are only the two things we can find. Now since we are finding the analytic function, so analytic function means it will satisfy Cauchy-Riemann equations. What are the Cauchy-Riemann equations? That is step 2. Step 2 says, since what is Cauchy-Riemann equation? Partial derivative of u with respect to x is my partial derivative of v with respect to y, that is ux is equal to vy, and partial derivative of v with respect to x is minus partial derivative of u with respect to y. So with the help of these two things we can express partial derivative of u with respect to x in terms of partial derivative v with respect to y, and partial derivative of v with respect to x in terms of minus times partial derivative of u with respect to y. So let us use these conditions in the derivative of the function, that is, let me clear this, that is since we have if we differentiate this function with respect to x, then f dash of z will be equals to derivative of u with respect to x, that is partial derivative. So that will be dou by u by dou by x plus I times derivative of v with respect to x, which is again a partial derivative, that is dou by v by dou by x. But now we only have partial derivative of u with respect to x because we have given u, isn't it? We don't have partial derivative of v with respect to x. But with the help of these CR equations, I can substitute partial derivative of v with respect to x as a minus times partial derivative of u with respect to y, because we have partial derivative of v with respect to y. So therefore f dash of z becomes partial derivative of u with respect to x minus I times partial derivative of u with respect to y. So here this derivative will be in the form of u and its derivative only. Now this f dash of z will be in the form of x and y. So what we'll do, we put x is equal to z and z equal to 0 into this. So we'll get f dash of z, which is partial derivative of u with respect to x, where x is z and y is 0, minus I times partial derivative of u with respect to y, where x is 0, x is z and y is 0. So now here f dash of z will be in terms of z only. So but we want f of z, so what we'll do, we'll integrate this function f of z. So therefore next step, this is step 3. Now step 4, that we want f of z, so integrating f dash of z with respect to z. So we'll get f of z, we get f of z in terms of z, in terms of z. Now to find, so f of z would be like this, f of z is equal to u plus iv. So we want to find v. So to find this harmonic conjugate v of u, we substitute, because we are having this function in the form of z, so we substitute z equal to, so to find v, put z is equal to x plus iy into this function, and then by separating real and imaginary part will be a value of v, or that will be a harmonic conjugate of the function u. Or so this we have discussed if the real part is given. Similarly, if the imaginary part is given, if the imaginary part of the function f of z is given, that is suppose second point, to find f of z if v is given, so where f of z is analytic. So if v is given, then all we are having as its derivative, we have function v of xy, so we can find its derivative with or we can differentiate this v with respect to x and with respect to y. These are the only two things we can find. So with the help of these two things, first of all we'll find f of z. How? So we'll differentiate. Suppose if we have f of z in the form of u plus iv, and if we differentiate with respect to x, then f dash of z will be partial derivative of u with respect to x plus I times partial derivative of v with respect to x. But we have only partial derivative of v with respect to x. We don't have partial derivative of u with respect to x. So to get this, we use the Cauchy-Riemann equation. That Cauchy-Riemann equation says derivative of u with respect to x is nothing but what? Derivative of v with respect to y, that is ux is equal to vy. So I can substitute this here. So therefore f dash of z will becomes derivative of u with respect to derivative of v with respect to y plus I times derivative of v with respect to x. Now here f dash of z will be in terms of x and y. So next step is we put x is equal to z and y equal to 0. We get f dash of z will be in terms of z, and then to get f of z in terms of z, we integrate this f dash of z to get f of z in terms of z, and then finally to get the harmonic conjugate of v, because we have given u, we have given v, so we have to find its harmonic conjugate u if we asked. Then to find the harmonic conjugate of v, we substitute z is equal to x plus iy into the last expression, and then by comparing real and imaginary part, the real part is nothing but the value of u, which is harmonic conjugate of v. So these two things are the methods of Milne Thompson method.